Welcome to session number 9. This is the benefits of continuous flow. Already completed 8 previous sessions, including value stream mapping, total productive management, standardized work, to name a few. This one's going to help get us ready, move us another step towards the desired goal of JIT. This is a non-technical game which will surprise you. It's called Sign and Deliver. The game demonstrates the differences between dispersed batch, co-located batch, and continuous flow. This game works best, I'm saying 5 to 10 students, but really any number can play. We can even break them into competing teams if we so choose to do. Dispersed, we place the odd and even participants on opposite sides of the rooms. Therefore, when one has to deliver to 2, 2 back to 3, and so forth, we maximize delivery times. Then we're going to set them and co-locate them, place the team members all in order at a long table. But we're still going to be batch processing. Then we're going to allow the members to set at that same table in order, and we're going to do some continuous flow work. For the instructor or coordinator, if this is used in a classroom setting, it's usually best to have about 10 students or so per team, and for each team you'll need 8 3x5 recipe cards and a stopwatch with a second hand and a copy of the scorecard, which you'll see later. We're assuming that all participants will have a pencil or pen. Just follow the rules of the game on the next slide. Good luck and have fun. Rules of the game. For the first 2 batch phases, student number 1 will sign 4 cards and deliver them to student number 2. Number 2 will sign all 4 cards and deliver them to number 3, and we'll repeat this down to the end of the team. After number 1 delivers the first 4 cards to 2, number 1 signs all 4 of the next 4 cards and delivers them to number 2. And we repeat this down through the end. In the third phase, the continuous flow phase, the student will sign 1 card and pass it immediately to number 2, who signs it and passes it immediately to number 3, and so forth down the line. After number 1 delivers the first card to number 2, number 1 signs and delivers the remaining 7 cards in order and passes them immediately when signed to number 2. And repeat this on down to the end of the line. Each team will need a timekeeper who times and records the times needed to complete the first, 4th, and final card, the number 8th card, and record these times on the scorecard. Now, here is the scorecard for sign and deliver game. We have the 3 rounds. We have the first, 4th, and 8th times for the first, 4th, and 8th processes or cards. With teams, you can turn off the video here and complete all 3 phases and have fun and come back. With an individual participant, you can just let the video continue. Review and think about and discuss sample results of a team of 5 that took this game in 2-18-12 on the next slide. Have your questions ready. That group went through this process, and here are the times for the 3 different approaches. Compare 522 for the dispersed batch to 353 for the co-located batch to 145 for the continuous flow batch. We kind of know what the difference between dispersed batch and co-located batch is. It's kind of obvious, right? But what is the difference between a co-located batch and a continuous flow? We know, for example, in the first case, the difference between dispersed and co-located batch processes is wasted delivery time. We saw it as students walk back and forth delivering their signed copies. But we still can't quite figure out the difference between the co-located batch and the continuous flow. Well, let's look at the next slide, provided courtesy of the Greater Boston Manufacturing Partnership. Maybe we'll find an answer. Here they show us using a 3-step process batch. Takt time is 1 minute. So to process the 10 parts in the first queue, it takes 10 minutes. Then they hand them off, or pass them to, deliver them to the second slot here. And again, takt time is 1 minute. It takes another 10 minutes to process all 10 of them there, and then they're delivered on to the third spot. Another 10 minutes. So the first unit is completed with 10 minutes in the first bin, 10 minutes in the second bin, and 1 minute in the third bin. That's 21 minutes, plus some delivery time. The last one is processed 10, 10, 10, 30 minutes plus some delivery time. Given continuous flow though, we make one pass one, make one pass one. So we start out with the 10 in bin 1, makes one, passes it to 2. Makes another one, passes to 2, who's already passed to 1 to 3. And all working on it. So yes, it still takes us 10 minutes in bin 1. But during that period of time, process 2 has processed 9 of them, and process 3 has processed 8 of them. So when we get done here, the first unit is processed, completed in about 3 minutes. And since they're co-located, there's not much travel time, so it's about 3 minutes for the first part to come off the end of that 3-step line. And the total processing time is 12 minutes, 10 plus 1 plus 1. That's the big difference between batch and continuous flow. Continuous flow is where we want to get to for JIT. TQM takes care of the quality of our processes. TPM takes the quality of our equipment. JIT uses customer pull, which we talked about in the value stream mapping session, keeps the costs down, and meets the delivery schedule that the customer requires. So let's wrap this up a little bit. We should always strive to get closer and closer to be able to produce what the customer wants when they want it. Continuous flow, sometimes called one-piece flow production, is the ultimate in flexibility and flow. We should always look for reasons we cannot produce in a continuous flow manner and apply countermeasures or Kaizen improvements to take away these reasons. Continuous flow is very important here as it ties into the overall lean enterprise concept. Any questions about this? Any comments? It helps the operators, it helps everybody. It cuts down on your real estate too. It really does.
How so?
By streamlining your line. One of the books has an example of a mattress factory in a building about the size of an old high school gymnasium, not these big fancy ones. And they had 7 different production lines in that factory, and the way they had it integrated and everything else, they could wait until they got the order and be able to ship it. And I forget how many different design patterns they had available. And they had very limited in-stock storage. Very limited. That would be an interesting book. I'll try to find that book and get that to you. Because it is very interesting that they could deliver the quantity of mattresses on demand. It wasn't just a black Model A Ford like Ford did. Give them any color they want as long as it's black. There was a lot of different variety in that, possible in those mattresses. Look for reasons so you can produce in continuous flow manner. Apply countermeasures to take away those reasons or Kaizen improvements, because this is the way to go. This is continuous flow. And that's the end of our show. So wasn't that fun? Interesting?
Quite interesting, yeah.
Yeah, it is. But there's a lot there. A lot there.